An index is a database structure that provides quick lookup of data in a column or columns of a table. Indexes are optional structures associated with tables and clusters that allow SQL queries to execute more quickly against a table. Just as the index in this manual helps you locate information faster than if there were no index, an Oracle database index provides a faster access path to table data. You can use indexes without rewriting any queries. Your results are the same, but you see them more quickly. Oracle Database provides several indexing schemes that provide complementary performance functionality. These are B-tree indexes, the default and the most common. B-tree cluster indexes, defined specifically for cluster. Hash cluster indexes, defined specifically for a hash cluster. Global and local indexes, relate to partition tables and indexes. Reverse key indexes, most useful for Oracle Real Application Clusters applications. Bitmap indexes, compact, work best for columns with a small set of values. Function-based indexes, contain the pre-computed value of a function/expression. Domain indexes, specific to an application or cartridge. Indexes are logically and physically independent of the data in the associated table. Being independent structures, they require storage space. You can create or drop an index without affecting the base tables, database applications, or other indexes. The database automatically maintains indexes when you insert, update, and delete rows of the associated table. If you drop an index, all applications continue to work. However, access to previously indexed data might be slower. Create an index if you frequently want to retrieve less than 15% of the rows in a large table. The percentage varies greatly according to the relative speed of a table scan and how the row data is distributed in relation to the index key. The faster the table scan, the lower the percentage, the more clustered the row data, the higher the percentage. To improve performance on joins of multiple tables, index columns used for joins. Primary and unique keys automatically have indexes, but you might want to create an index on a foreign key. Small tables do not require indexes. If a query is taking too long, then the table might have grown from small to large. Some columns are strong candidates for indexing. Columns with one or more of the following characteristics are candidates for indexing. Values are relatively unique in the column. There is a wide range of values, good for regular indexes. There is a small range of values, good for bitmap indexes. The column contains many nulls, but queries often select all rows having a value. In this case, use the following phrase. Where COL_X minus 9.99 asterisk power, 10,125. Using the preceding phrase is preferable to where COL_X is not null. Columns that are not suitable for indexing are. There are many nulls in the column, and you do not search on the not null values. Long and long raw columns cannot be indexed. The order of columns in the create index statement can affect query performance. In general, specify the most frequently used columns first. A table can have any number of indexes. However, the more indexes there are, the more overhead is incurred as the table is modified. Specifically, when rows are inserted or deleted, all indexes on the table must be updated as well. Also, when a column is updated, all indexes that contain the column must be updated. Thus, there is a trade-off between the speed of retrieving data from a table and the speed of updating the table. Consider dropping an index if it does not speed up queries. The table could be very small, or there could be many rows in the table but very few index entries. The queries in your applications do not use the index. The index must be dropped before being rebuilt. Creating an index on a table that already has data requires sort space. Some sort space comes from memory allocated for the index creator. The amount for each user is determined by the initialization parameter sort_area_size. The database also swaps sort information to and from temporary segments that are only allocated during the index creation in the user's temporary table space. You can parallelize index creation, much the same as you can parallelize table creation. Because multiple processes work together to create the index, the database can create the index more quickly than if a single server process created the index sequentially. When creating an index in parallel, storage parameters are used separately by each query server process. You can create an index and generate minimal redo log records by specifying no logging in the create index statement. Creating an index with no logging has the following benefits. Space is saved in the redo log files. The time it takes to create the index is decreased. Performance improves for parallel creation of large indexes. Use unusable or invisible indexes when you want to improve the performance of bulk loads, test the effects of removing an index before dropping it, or otherwise suspend the use of an index by the optimizer. An unusable index is ignored by the optimizer and is not maintained by DML. One reason to make an index unusable is to improve bulk load performance. Bulk loads go more quickly if the database does not need to maintain indexes when inserting rows. Instead of dropping the index and later recreating it, which requires you to recall the exact parameters of the create index statement, you can make the index unusable and then rebuild it. When skip_unusable_indexes is false, then if any unusable indexes or index partitions are present, then any DML statements that would cause those indexes or index partitions to be updated are terminated with an error. For select statements, if an unusable index or unusable index partition is present, but the optimizer does not choose to use it for the access plan, then the statement proceeds. However, if the optimizer does choose to use the unusable index or unusable index partition, then the statement terminates with an error. You can create invisible indexes or make an existing index invisible. An invisible index is ignored by the optimizer unless you explicitly set the optimizer_use_invisible_indexes initialization parameter to true at the session or system level. Unlike unusable indexes, an invisible index is maintained during DML statements. Although you can make a partitioned index invisible, you cannot make an individual index partition invisible while leaving the other partitions visible. You can create multiple indexes on the same set of columns when at least one of the following index characteristics is different. You cannot create a B-tree index and a B-tree cluster index on the same set of columns. You cannot create a B-tree index and an index organized table on the same set of columns. The indexes use different partitioning. Partitioning can be different in any of the following ways. Indexes that are not partitioned and indexes that are partitioned. Indexes that are locally partitioned and indexes that are globally partitioned. Indexes that differ in partitioning type, range or hash. The indexes have different uniqueness properties. You can create both a unique and a non-unique index on the same set of columns. Different types of indexes are useful in different scenarios. For example, B-tree indexes are often used in online transaction processing, OLTP, systems with many concurrent transactions, while bitmap indexes are often used in data warehousing systems that are mostly used for queries. Similarly, locally and globally partitioned indexes are useful in different scenarios. Locally partitioned indexes are easy to manage because partition maintenance operations automatically apply to them. Globally partitioned indexes are useful when you want the partitioning scheme of an index to be different from its table's partitioning scheme.